Hello, and welcome to this clinic on creating round things for model railroads. I am Dave Ackman of the Gateway Division of the NMRA in St. Louis. My favorite parts of model railroading include creating structures and cars for my railroad and teaching clinics on how I do so using 3D printing technology. Today, we will focus on creating 3D object models with curved surfaces, round things. But first, because 3D printing is still a new technology to many model railroaders, we will start with a very brief overview of 3D printing, the difficulty involved, what it costs, and how it works. We will show a few examples of models created by other folks that you can download for free from the internet, and then show models I have custom designed myself but are mainly rectangular. Then we will show how to create round things of our own using TinkerCAD and my own generators, and finally, solids of revolution. I like to say that if you can handle DCC, you probably can handle creating models for 3D printing. You can start by downloading models you like from libraries, especially for HO. And if you like scratch building, you can then learn more about creating objects of your own design. And you can get started with your own printer for about $400, or $300 if you are on a very tight budget, but Daddy always told me to buy my last tools first. I don't recommend specific printer models, but I do use a Bamboo P1S model I bought in January of 2024, which now retails for $400. Actually, I have two of them. Previously, I had two less expensive printers from a different manufacturer, and one failed and I junked the other due to poor support from the manufacturer. Nuff said. Early on, I was seduced by early adopters to use complicated software capable of performing rocket science. But I soon learned two things. First, I wanted to do model railroading, not rocket science. And secondly, I could simplify the modeling process through simple tools, like TinkerCAD and some programs I wrote called generators. Keeping things simple is a good idea. To print an object, you must first have a digital model of the object you desire. Models are often stored in the stereolithography, or STL, file format, which may be created by or transferred between CAD packages for further enhancements, or imported by slicer software for printing. More about slicers shortly. STL files are your friends. If you are going to print a model on your personal 3D printer, the STL files must be translated into instructions for your specific model of printer by software called a slicer, which typically is provided with your printer, and then transferred to your 3D printer in much the same way that you would print on a standard paper printer. Alternately, you may send the STL file to a service bureau for them to print and return to you, a process I do not recommend due to turnaround times I deem unacceptable. Service bureaus were often used in times gone by, before the prices of 3D printers fell to acceptable levels, but to me are no longer worth the expense or hassle. If you don't want to create your own models, there are several websites that offer them for free or for a small fee. I particularly like the freebie models posted by K.A. Brumble on Thingiverse.com. Kim is an exceptionally gifted modeler, has posted about 300 model files, many being rectangular structures, and his work has taught me a lot. Here are some samples of custom models I have created, round and otherwise. Some, like the water tower, use round components extensively, while others, like in the lower right, have a few round components, especially roofs. You will see how these and more are created throughout this clinic. But this clinic is focused on the creation of custom round things, and we will do so from three perspectives: creating rounded structures and accessories with a simple free package, TinkerCAD; creating more complicated objects with free tools I have developed and called generators; and creating objects called solids of revolution in TinkerCAD. This clinic will not teach you all the gory details, but hopefully will get you thinking out of the box of rectangular shapes and bend your brain into considering the possibilities for creating custom round things. Let's start with a simple propane tank. Such a tank with a capacity of 1,000 gallons would be 16 feet 2 inches long, or 6.78 meters, and 41 inches in diameter, or 1.04 meters. Scaled down to HO, this comes to 56.7 millimeters and 11.96 millimeters. To start, we drag a shape, in this case a sphere, from the toolbox and drop it onto the build plate. When TinkerCAD objects are added to the build plate, they usually are 20 millimeters on a side, so we need to resize the sphere to 11.96 millimeters, and do so by clicking on the white square at the corner and entering 11.96, then the Enter key. This alters its size in one dimension, so we click on another white square to alter it again, and then we click on the square in the middle to alter its height. We now have a suitably sized sphere. A propane tank has two ends, so let's copy and paste the sphere onto the build plate and drag it out of the way. We need three more components for our tank: a cylinder connecting the spheres, a dome on the top, and some legs. We click on the cylinder tool and drag it to the build plate, but it's the wrong size and orientation. The cylinder needs to be 56.7 millimeters, including the end domes, so we must subtract 11.96 millimeters, resulting in 44.74 millimeters long. This is the total length of the tank minus the size of the two hemispheres at the end. We could click on the white square handle in the center and drag it into position, but I prefer the precision of entering the exact dimensions into the box. But the cylinder is standing on its end, so we need to rotate it. When we click on it, a rotation arc appears, so we click on it to rotate the object. If we keep the cursor in the inner ring, it rotates in increments of 22.5 degrees. But if we move the cursor to the outer circle, we can rotate it any number of degrees we wish. Or finally, we could just enter 90 degrees or any value we want. Now, let's select the cylinder and the two spheres and align their left edges with the alignment tool. We will drag the cylinder 5.98 millimeters to the right and the right sphere 44.7 millimeters to the right, then align their tops and group them into a single shape. You now know the basics of TinkerCAD. All that is left is to create another small sphere for the dome, which we can do in one operation by shift-clicking on a white control point and dragging it to the desired size, and add a pair of small rectangles for legs, and we have a propane tank, our first round thing. Our propane tank was a solid object, but few things are solid on a model railroad. So our next exercise is to construct a simple semi-cylinder outbuilding for a layout room. Let's start by dragging in a cylinder. The shape is solid, but we will address that issue shortly. Our next task is to lop off the front half of the cylinder. We are going to click on the tool which looks like a gray rectangle. This is the Hole tool, and we use it to remove parts of other objects. I am going to drag it onto the build plate and shorten its depth to 10 millimeters, half the side of the cylinder. I now align the bottom of the two shapes and their centers and then group them. Presto! We have a semicircular cylinder. It's still a solid, but keep the faith, we'll get there. Next, even though our layout room is standing on what will eventually be its back wall, let's establish its overall dimensions. For this project, let's create a room with a footprint of 20 feet wide, 35 feet deep, and 12 feet at the peak. We already know how to size objects by clicking on a corner or side handle and then entering our desired dimensions, so we convert our dimensions to 70 millimeters wide, 122.5 deep, and 42 millimeters tall. Just for grins, let's stretch its height to 50 millimeters. Our cylinder is no longer a perfect hemisphere, but we like it that way. Let's make 2 copies and move them to the side. Now, back to converting our solid cylinder into a hollow shape. We need to decide how thick our walls are to be, and I like 2 millimeter walls, representing real walls a bit over 6 inches. No problem. We just take one of the copies, reduce its width from 70 millimeters to 66 millimeters, 2 millimeters on each side, and its height from 50 millimeters to 48 millimeters. And now for the trick. We change its color from some solid into a hole, then align it with the exterior walls, and finally group the 2 shapes, resulting in a hollow cylinder. I like to print my hollow shapes standing on their ends, because I think it gives a smoother surface than if printed on the bottom of its 2 sides. You are probably wondering what we are going to do with the other copy we made earlier. It is going to be our end wall. Take it and reduce it to 2 millimeters thick, and then use the hole tool to insert windows and doors as you see fit. Make another copy for the other wall. A standard exterior door in HO is 10.5 millimeters by 23.33 millimeters. Awnings in TinkerCAD can be a lot of fun, and we are going to learn several new tools to make them, starting with the Extrude Sketch tool. The Extrude Sketch tool is shaped like the nib of a fountain pen, if you are old enough to remember those, and lets you draw freeform objects. We are going to use it to draw a profile of an awning. We start by dragging the tool onto the build plate. The screen changes to a 2-dimensional grid, which we can pan and zoom as with most other windows. Now several buttons appear on the left edge of the grid. The upper one creates straight lines, and the next one down creates Bezier curves, and we will click on it. Now we just move the cursor anywhere we like and click and release to draw points for the shape. For an awning, let's create 2 points. Then on the check button to indicate we are done drawing an open path. We now see a new tool, a triangle inside an arc, which is the tool to edit, modify a selected shape, and we click on it. Now down at the bottom are 2 new tools, and the one on the right allows us to modify the shape's stroke settings. I am going to click on the point at the top and more tools appear. The one now on the bottom right is a brake handles tool, and I am going to click on it. A handle appears as an orange rod, and we can drag around the opposite end to change the shape to define the profile of our awning any way we desire. When we get a profile we like, we click on Finish Sketch. Once back on the main build plate view, I am going to create 2 copies of this arc, and double-click on one of the copies to reopen the sketch screen. I will click on the arc to select it, and then click on the button to modify the arc from a line to a plane. Buttons appear at the bottom of the screen, and I click on the one on the left to close the path. Now I want to add a point, and there is a tool on the left side of the screen which does just that. So I click on it and add a point to the middle of the straight line. One point is enough, so I click on the tool to modify and edit the design. I click on my new point and drag it to a corner for the arc, and then on a finished sketch, and just like that, we have an end cap for the awning. Let's change the height of the arc to 70 millimeters, 20 feet in HO, and the end cap to 1 millimeter, and make another copy of the end cap. Now we align the arc and one end cap and group them, and then do another operation to the other end cap, and we have our awning. But we still have an arc left over, and we are going to use it to create some awning ribs. We start by reducing the thickness of the arc to 0.6 millimeters, or some thickness you prefer. Now I am going to introduce a new tool, the Duplicate tool in the upper left, which looks like 3 offset squares. This tool is somewhat like a copy and paste operator, but whereas a copy and paste places the new object a bit offset from the original, the Duplicate tool makes a new object directly over the original, duplicating it in the same place. TinkerCAD calls this tool Duplicate and Repeat for reasons which will become apparent shortly, but I refer to it as the Dip tool, Duplicate in Place. So let's click on this arc, and then click once on the Dip tool. A duplicate will be superimposed on the original. It will not be visible as a separate object, but trust me, it's there, and is the currently selected object. Now let's grab the Elevation tool and raise the new object 4.8 millimeters, but do not enter a carriage return. We now see both objects. Because the Elevation tool does not move objects in the X or Y direction, the new arc is directly over the old one. Keep the new object selected, or else the magic you are about to see will not work. Now, click on the Dip tool 11 more times, and we get 11 more duplicates, each perfectly aligned and separated from its brother by 4.8 millimeters. We now lasso them all and turn them into a group. Our awning is 70 millimeters, and the ribs will be something close to that, but alter their group height to match the awnings. We are almost done. Select the ribs and the awning and align them. Carefully drag the awning down and to the right about 0.5 millimeters or some other distance a bit smaller than the height of the ribs. And group the awning and the ribs. Abracadabra! We have our awning. To achieve the smoothest awning surface, I like to print the awning standing on end, but this can cause problems when taking the awning from the printer, wherein the end cap breaks off. To get around this problem, I elevate the awning a small amount, perhaps 5 millimeters, and place a small stem directly under the awning, not even touching. Then group the two. This prevents the awning from touching the build plate when printing. Then, when slicing, I invoke standard slicer supports, then print. When done printing, the awning breaks off the supports and stem nicely, with no damage and a clean print. Originally, I created a generator for awnings, and it is still in the generator collection, but this process is much more versatile. This awning is convex, but concave awnings are just a matter of rotating the top handle counterclockwise rather than clockwise. I have included a video specifically for this process as a tip and trick for your reference. Sometime in the future, I will add an additional tip on how I mask the awning for painting adjacent segments in contrasting colors. It's a neat enhancement. Maybe I'll add fringes along the bottom too. I just love awnings, sketching, and the dip trick. Before we leave TinkerCAD, I want to show you a trick which will be useful if you want to design EMD diesel locomotives. Diesel hoods are often rectangular, but with rounded edges between the top and the sides. We could create such a shape with a combination of rectangles, spheres, and cylinders, but TinkerCAD has an easy way. Just draw an elongated cube and then slide the value of the radius a bit to the right, and we have rounded edges. We probably also want to use the hole tool to square off the bottom edge as well as the side near the cab. Hopefully, by now you have a general idea of how to create round things for your layout in TinkerCAD. It's not too hard, but possibly harder than it needs to be. Before I retired, I was a computer scientist, and as I aged, I found it difficult to create increasingly sophisticated components for my models by drawing them. Getting the dimensions sized properly was getting tougher. Curved shapes were getting harder to design. My mind could conceive more than my hands could create. So I decided that I needed a better way. A way in which any modeler could specify the dimensions of a desired object in a form, and have a computer program create a model without any manual dexterity required, kind of like making the parts for my own kits. And I call these programs generators. They are available from my website, http://daakm.github.io. They run under Microsoft Windows and are free. Some even have documentation, and I'd like to share them with you. One of the first generators I designed for round things was for corrugated roofing. I already had a generator for flat, tabular, and board and batten roofing, so corrugated metal roofing seemed like a no-brainer. There are parameters for width and depth for a sheet, and one more for the displacement, or radius, of each cycle. The total displacement of the height peak and the lowest valley is twice the corrugation radius. To turn a design into a model, we just click on the green Generate button and specify the name of a file. The model will be saved in a .scad file to the folder of your choice. But what is an SCAD file? SCAD is a file format used by another free program called OpenSCAD. SCAD files are scripts that describe 3D objects. You need to know very little about how OpenSCAD works. After all, do you know how to build an internal combustion engine, but you can drive a car? All you need to know is how to import an SCAD file, view the model, and if you like the model, you hit the F6 key to render it in fine scale, and then hit the STL icon to create a stereolithography file suitable for printing on a 3D printer or importing into TinkerCAD for further enhancements you learned a few minutes ago. The OpenSCAD program is available for download at http://openscad.org. Next, let's look at a round silo or storage bin with corrugated steel walls. You have control over the footprint of the object and also control the size of the corrugations. When you are satisfied with your design, you can save the parameters to a file on your PC and then reload it when you wish to make another copy of your design or share the design with someone else. We could have designed our layout room with corrugated metal and done so easier than in TinkerCAD, just by designing a silo and then creating a hole to lop off one side. The generator really could use a feature to create domes, but I don't enjoy programming domes, so this will have to wait until I get around to it. Here we see silo samples created in the generator, both full cylinders and one I imported into TinkerCAD and added doors and window fixtures. Eventually, the silo generator will also have the ability to create brick silos. Why would anyone want a brick silo? Well, the cylinders could be sliced like a pie to create a rounded building corner, like for the Flatiron Building in Manhattan, or for a turret in a downtown loft, for glass bricks in an Art Deco structure, or chimneys. Next is another generator for arched roofing. It can create roofing that is more sophisticated than we did with TinkerCAD alone. This generator allows our roofs to have splines simulating rafters on a barn. It also can create roofs which do not end perpendicular to the ground, vertical legs which attach to the arch, and masks to turn board and batten walls into pieces that attach perfectly at the ends. I used the arched roofing generator to create the roofs for Stem's florist and Petunia's greenhouse. A trellis is similar to the arched roofing generator, just the splines without the roofing. I used some foliage sheeting from Woodland Scenics to cover the splines and sprinkle some flowers on the top and underneath. Some LED lighting might make an interesting tunnel for a Christmas layout. I always wanted a circus tent, so I made a generator to create both the round end piece and the straight piece that would join the ends. Controls exist for sizing the triangular pieces, the number of them, and the amount of curvature from the top of the skirt to the top of the pole. I also made a mask to facilitate the painting of the triangular pieces. This is a really large structure, and I printed it in pieces, using thin, curved pieces to support the undersides where they intersected. I was not as pleased with this as I had hoped. Maybe it is worth hundreds of dollars to buy a cloth tent. This water tank in Carpenter, Illinois, was the inspiration for the whole round thing idea. There are indeed multiple round things in this project. A generator allows me to alter any of the parameters. The tank itself is a cylinder with squashed spheres on the top and bottom. The catwalk is a collection of about 9 concentric hollow cylinders with radial arms, a handrail reinforced at the catwalk, and a large hole in the middle sized to match the tank for a friction fit. The generator is smart enough to be able to create tanks with any number of legs between 3 and 12. With controls for their diameter and angle from vertical. To keep the tank stable, we have horizontal compression arms between the legs and angled tension arms to keep the legs in place. Then there is the ladder and cage. This was pretty simple, but figuring how the ladder should pass through the catwalk took some thinking, since I never could get close enough to the prototype to see how it was done. And the ladder had to be positioned such that the horizontal support arms intersected the compression arms. There is a lot of geometry and trigonometry involved in this project, and I don't think I could have maintained symmetry if this thing had been drawn in Fusion or other non-scripting CAD package. Oh, there is also an Arduino microprocessor that flashed CARP on the LED at the top of the tank. There are probably 100 hours of design and testing in this project. If you launch TinkerCAD and search for round things, no spaces, you will see a design for fascia tags and luggage tags. I use fascia tags to label the towns on Gateway Division's Fremo layout, and you can modify the text to suit your needs. In the lower right is a module number we use to remind us of the module's location along the line, and you can keep this or delete it as you desire. The holes are for number 6 screws. I also created a luggage tag just because I always need luggage tags. You may want to left align the text after modification. Modifying text in TinkerCAD is a bit clumsy, but highlight the block you wish to change, delete most of the letters, add your text, and then delete the rest of the surplus letters. If you try to delete them all and then add the new text, it often fails. I would call that a bug. The first generator I ever created was for flat, four-sided buildings. In addition to walls of boards and battens and clapboards, I designed for log cabins, and logs are round things. The walls are really pretty basic, but do allow for planed logs so they don't roll off each other, as well as overlapped ends. It was a fun project. Here is the generator for spiral staircases. Depending on the size of the staircase inner diameter, the software can create either staircases for interior residential buildings or larger ones for the outside of chemical or other large surface storage tanks. You can also control the frequency of large platforms on which climbers can rest. The interior staircase is pretty delicate and may not print well on a filament printer. I built in the ability to create a tank and staircase together, as the tank supports the staircase when printing, but depending on the size of the steps and the capabilities of your printer, slicer supports may still be required. Maybe one day I'll add a dome or cone topper for exterior tanks to this generator, if I ever get around to it. Earlier, I confessed that while my silos, spiral staircases, and water tanks needed domes, I disliked programming them into generators. The fact is, they can be complicated to program, and frankly, they are not that difficult to draw in TinkerCAD. So, what do I propose? There are 4 steps. First, draw a sphere the outside diameter of the silo, tank, or other cylinder you wish to top off. Next, turn the sphere into a hemisphere by adding a rectangular hole to the bottom, 1/2 as tall as the sphere, but big enough to span the bottom. Then align the centers and the bottom, and group the shapes to lop off the bottom, and drop the group to the build plate by entering a D for drop from your keyboard. Now measure the inside of the tank or silo, determine the diameter, and draw a cylinder to the diameter you measured, or perhaps 0.2 millimeters smaller, and about 3 or 4 millimeters in height. Finally, drop the cylinder a few millimeters below the build plate, but centered on the bottom of the hemisphere, and group the shapes. You now have a dome suitable for your needs. Of course, you could alter the height of the dome to squash it, even down to several millimeters for use on a petroleum tank. Or you could use a cone instead of a sphere to cap off a line-side water storage tank for a steam engine. Round things are not limited only to structures. Tools for creating round things can be constructed as well. Consider the scallops on the front wall of my Stems Florist, or the facade of many buildings on mid-19th century Western railroads. They are easy to make once you have a TinkerCAD cookie cutter. We start by determining the radius of the scallop. If I am working from a photo, I do this by counting the number of bricks in the scallop, a standard U.S. brick being 8 inches long and 2 inches tall. Thus, if the curve was 5 bricks tall, that would be a radius of a bit under 12 inches once we add in the mortar. So let's round that up to 7 millimeters in HO. I'll draw a 14 by 14 millimeter cylinder with an arbitrary height of 5 millimeters, then lop off the bottom half to make a semicircle. If you are working from a freelance design, well, just follow your own muse on the sizing. Now let's determine the run from the top of the scallop to the bottom of the next scallop. Again, I will count bricks, and let's assume there are 4 bricks, which comes out to be about 3.8 feet or about 13 millimeters in HO. I'll draw a rectangle 7 millimeters tall and 13 millimeters long and move it over to the top of the semicircle and group them. My shape is now 7 by 20 millimeters. Next, I will draw a rectangle 20 by 30 or some other convenient height with a thickness of 5 millimeters. I will change the scallop shape into a hole and align it with the lower left of the new rectangle. Because there can be a small rounding error in TinkerCAD, I am going to move the new rectangle up just 1/100th of a millimeter and then group the two shapes. Finally, I will change this group into a hole. I now have a cookie cutter for a scallop. I'll just make copies of the cutter, move them around over my original wall, and group them, and we have a scalloped facade, a great new but somewhat unexpected round thing. You probably would want to be more careful about aligning the wall and the cutters and move them digitally, whereas here I was not so careful in the positioning, but you get the idea. Round things helped me get my structures certificate in the NMRA Achievement Program, but I am not stopping there. It's on to cars. A tank car is not much different than a propane tank. Yes, we need to create a grid and saddle for the base plus an underframe. The Achievement Program requirements permit us to scavenge trucks from a car we have otherwise junked, and we can add brake and dome details, rivets, handrails, and custom decals. I didn't say it would be easy, but it is approachable. Will I make a generator for a tank car? Yes, so I can create different sizes and ones with different underframe features. Will I make it available on my website? Probably not. Making bulletproof generator software is not easy, and frankly, I have not seen enough usage among structure modelers to encourage me to start them for cars. So the generators I create for cars will be for my own use. Another one of my AP cars will be a coil car, and coil cars need hoods to protect the coils. Here you see rounded and bevel hoods I created in a generator displayed on an Intermountain 55-foot coil car. I created the stacking support arms and the lifting point using TinkerCAD. These hoods could also be created without a generator using TinkerCAD, and more about that later. I used TinkerCAD to create spools for industrial cables and the wire to go around them. These two components are on my website under Additional Downloadable Models for Structures and can be resized and printed in different colors in TinkerCAD as desired. I also created an assembly jig using 3/32 brass rod and ultra-high molecular weight polyethylene, or UHMW, to prevent glue from sticking to the wood block. With appropriate cribbing, these might look good as open loads on a flat car. A bit earlier, I stated we could make coil car hoods without a generator using just TinkerCAD. It's just a matter of making a solid shape and hollowing it out. But because the hollowing technique is so important to 3D modeling round things, I want to go over it again, just so I know you know how it is done. We first need to know the hood's exterior dimensions, which are 28 millimeters wide, 85.15 millimeters long, and 22 millimeters tall, with a wall thickness of 1.00 millimeters. You could have determined that yourself just by measuring one with a caliper. To me, the profile looks like a semicircle with a rectangle below, so I am going to draw these shapes. I am going to start with a round roof shape, the one that looks like a blue semicircle, and resize it to 28 millimeters wide and 14 millimeters tall, its radius. Using the elevation tool, I am going to raise the semicircle 8 millimeters above the build plate, which is the 22 millimeter height of the hood, minus the 14 millimeter height of the semicircle. Similarly, I am going to bring in a cube and resize its width to 28 millimeters and its height to 8 millimeters. Now I will align the semicircle and the rectangle in the two side dimensions and group them. Finally, I will stretch the shape 85.15 millimeters and we will have a solid shape the size of the hood. Now I am going to make a copy and reduce the side dimensions by 2 millimeters, the length by 3 millimeters, and the top by 1.5 millimeters and turn it into a hole to make my interior. I'll make a copy of this hole and set it aside. Now align the centers of the two large shapes, group them, and bingo! We have our hood, and not all that difficult. Just add the top appurtenances and we are there. But just to make sure you have what you need, I have a TinkerCAD model I made public under my DAACKM handle, so just search for it and get started. With the remaining copy of the hole, I am going to reduce its height to 0.5 millimeters to use as a recess for the end caps later on. Could we have made a hood with a beveled top? Sure. Just start with the green triangular roof shape, make it 28 millimeters by 14 millimeters, lop off the top 5 millimeters with a rectangular hole, elevate it 13 millimeters, and go from there. I'll leave hollowing the end caps and drawing their bracing to you. Why should I have all the fun? Now I am going to present the lunatic fringe of round things, solids of revolution. Solids of revolution are the potter's wheel of CAD software. This functionality takes 2D objects and spins them around an axis to create 3D objects. In the fall of 2025, TinkerCAD introduced its own version of Solids of Revolution, which combines its drawing tool with rotational capabilities. You just select the tool and click on the build plate to place it as desired. Then it's click, click, click as you draw a shape, similar to how you would use the drawing tool in PowerPoint. A point is placed when you release the mouse button, not when you press the button, which seems odd to me, but that's how it works. When done, you can enter edit mode and move the points around or change them from sharp to smooth, altering tangents with a click, hold, drag maneuver on the orange handles. When the design is satisfactory, the tool can be finished and the object extruded 360 degrees or any fraction thereof. I think this is a promising enhancement to TinkerCAD. Using the same tool, I am attempting to create a fountain. Here I created one spout, made it 1 millimeter wide, and finished the shape. Then in the Shape Control panel, I altered the sweep angle to 2 degrees. I made a copy, flipped it, moved it to the left, and grouped them. Then, using the Duplicate in Place tool, I made more copies and rotated them until I had 16 spouts separated by 22.5 degrees. When I get around to it, I want to print this in clear filament and try illuminating it with colored LEDs and an Arduino controller. As I write this clinic, it is the last day of 2025, and to date, the most sophisticated round thing I have created is a solid of revolution of an ice cream cone to eventually attract customers to an ice cream stand. I plan on placing a steel rod up the center and spin it on a motor driven by an Arduino microprocessor. Perhaps I'll add some calliope music to bring in customers. So what's coming next? Round barns are a thing and are more common than you might think. Just think of them as upside-down versions of two parts of the ice cream cone. The addition of arches atop the windows of my Windows generator is long overdue. Then there are Adirondack chairs, round picnic tables, patio tables, bird baths, chandeliers, and igloos, which perhaps we can morph into an ice skating rink. Maybe in 2027 I'll break through to the roundest of all round things, people. During COVID, I discovered software called Make Human, which designs posable human figures suitable for 3D printing. Back then, I got it to work, and I created figures that I could configure specific desires, but I never got proficient at it, at least enough to teach it and answer questions. A 6-foot human in HO is only 21 millimeters tall, and that may be too small to get the details I want from a filament printer. I may need to enlist the aid of a friend who uses a resin 3D printer, which can give finer details, but has issues of its own. Or perhaps I'll wait for technology to advance. Anyone else interested in taking the lead? Like most of model railroading, we are limited only by our power of observation, our creativity, and our skills in construction. I hope you enjoyed the show. Thanks for watching.